Welcome back, boys and girls. Today I'm going to be doing an introduction to the Clojure programming language for C# developers. If you're a .NET C# developer, if you've ever been curious about Clojure, this is your chance to find out because I mention it quite a lot. People ask me, how do you know what you know? And part of it I attribute to Clojure and the epiphanies that I had while programming in it. So take this as an inspiration, and the bottom line for Clojure really for me is that it's going to change the way you think if you attempt to program in it. It's going to be a painful experience, but it's going to be a good one in the end. Now, Clojure is a functional programming language primarily with built-in immutability and other things that really force you to think a different way. F# is another programming language on the .NET ecosystem which is functional. I don't know if it evokes the same epiphanies. I know some of you are doing F#. If it does, go ahead and leave a comment. I don't program in it. I am not gonna try it. Don't ask me to, okay? So don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, make sure to leave them in the comment section. I have a C# course that is out. If you would like to know C# as I do, I highly recommend you take a look at it. With that, let's go ahead and get started. So I am using VS Code for this because VS Code actually contains an extension called Calva, which makes working with Clojure really easy. And by the way, for the installation of Clojure, I'm assuming you are all adults and you can Google install Clojure and figure out how to install Clojure for your operating system. For Windows, I would recommend go the WSL route, okay? So here we have a couple of files. Let me zoom in a little bit more. If we open up deps.eden, this is your CS project file. This is your configuration for the project. It specifies dependencies and other things. This configuration over here starts a read, evaluate, print loop, also known as a REPL. Whenever you type in Python in your terminal, you're gonna enter into a REPL, where you can just type some code and it is going to get executed. Otherwise, I have two CLJ files where we're going to be doing some exercises, and that's pretty much it. So first of all, what you need to do is you need to start up a REPL. For this, you will need to find your Calva extension commands, and you're going to connect to a REPL. You're going to start your project REPL, right? This is gonna choose deps.eden file. You're gonna choose your REPL server configuration. You're gonna press OK, and there we go. So everything is a little bit zoomed in. The REPL here has started. I'm just gonna close the terminal, and here is a file where I can start executing Clojure. So for example, if I say I want to evaluate 1, it's going to evaluate to 1. If you understand the word evaluation and what it means, everything in Clojure is a function. 1 is a function that evaluates to itself. I don't need to work in this file. I can go into main.clj, and here I can try to evaluate 1. The way that I do it is I'm gonna do Control Enter, and that's just going to evaluate it. You can go into settings and keyboard shortcuts, and here you type in Calva and look for some evaluation commands. You can evaluate the whole file or one command at a time. But what this is going to do is it's going to take 1. Let's pick a different number so we can actually see it. We are asking to evaluate 5. That evaluates to a 5, and it gets sent over here. So you have a history for everything that you execute, okay? Coming back to main CLJ, if we want to do a canonical print hello world, we don't invoke functions like this like we do in Python. Instead, what happens is you specify some kind of parentheses. You say what function you want to invoke and then the parameter. So in here, it would be hello world. Invoke this. Now, the return value of the print function is null. All functions in Clojure have a return value. What this is going to do is print the hello world to standard output. You will see it here, and if you're running it from the console, you will see it there. However, you still get the return value, okay? Now that we understand that we have values and that we can execute functions, let's bridge the gap between functions in C# and functions in Clojure. If we have a function like add with 2 parameters, all that you are doing is if we place add over here, we're taking this parentheses and we're placing it on the start here. There are no types, and we will be replacing these with numbers, and that's how it looks like, okay? Commas are absolutely optional. They are basically white space, okay? The add function in Clojure looks like this. It's just a plus. If we evaluate this, we will get 11, all right? Now, if you squint, this may look like a collection, and that's because Clojure is a flavor of Lisp, which is just built around lists. So if we may say we want a list in C# that looks like this, omitting all the new list and all of that malarkey, list is kind of like a base construct in Clojure. If we want to create a list, there is a list function, and we would give it parameters like 1, 2, 3, 4, and this will evaluate to a list. We can also create a vector, so vector, not vectory. If we evaluate this, we can see here are square braces. So the difference between a list, it's a linked list, so it's fast appending at the beginning. Vector is an indexed collection, so this would be something like an array or a list. We then have sets, which are denoted by the hashtag. So 1, 2, 3, 4, and let's say I will add another 4. You can see here that it's telling me that the syntax is incorrect because a set can't have duplicates, right? So I will have to remove this. And then we have dictionaries. Again, I can say 1, 2, 3, 4, and it's a key, value, collection. And if I evaluate this, this is what it's going to look like. Now, vectors and lists, you don't have to write them like that. For vectors, we've seen that we've been using square braces. If I take this and place this over here, this is still the same vector. If I evaluate this, it's still the same. Now, lists, when we evaluate this, if we take a look at it, it's using regular parentheses. So it looks like as if we would be able to write it like this. However, it's actually expecting a function invocation at the beginning. So what we have to do is we have to actually quote it at the beginning. The quote mark over here is actually just a function. So if we bring up a quote, 1, 2, 3, 4, this is what it actually looks like under the hood. So if I evaluate this, it's the same as this, okay? Let's go ahead and get rid of this quote. Looking at this, you almost know the entirety of the Clojure programming language syntax. We have values, which are functions which evaluate to themselves. We then have functions, which are just functions that can be invoked. We have 4 primary data structures: lists, vectors, sets, and maps. Or if you're not comfortable with maps, you can think of this as dictionary. Other things that you have are keywords. So for example, Anton, this can be a keyword. It's almost like a symbol. Imagine if you could store a variable name in a variable, okay? So it's that sort of thing. And again, a keyword is a function that evaluates to itself. You can have functions like type. So if we evaluate this, it is of type keyword, okay? So the programming language is dynamic, however, you still have types. If we take a look at type of 5, we will know that it is a long. And if you're seeing Java over here and you are about to get scared, yes, Clojure runs on the JVM, and Clojure can actually also run on the CLR. Maybe sometime in the future, I will show you how to run it on the CLR. And lastly, what we have are regex patterns. So if I'm looking for something that contains a bunch of words, this is how I would define it. Again, if we take a look at the type of this, so to the beginning, and by the way, Calva introduces a lot of custom keybinds where all you're doing is you're really just moving parentheses. So if you're wondering how am I pushing a parentheses to the end, it's custom keybinds, okay? If I evaluate this, you're gonna see that it is a regex pattern and you automatically get it essentially. At this point, this is pretty much it. You've learned the entirety of the Clojure programming language syntax. Now all that's left is to just learn all of the functions that are available to you, and there is quite a lot, and generally all you will do is you will say, in Google Clojure, how do I do X? And it's going to show you the correct function to use. Okay, so that will be your development experience with Google. For defining global constructs, you would use def. Let's say we will define some kind of word and it's going to be bird. Okay, we define word. If we want to evaluate word, because it is not a function, we can't actually evaluate it like that. Let's get rid of parentheses and just evaluate the word bird on its own. If we want to actually stick this word into a list, we would have a list function and create a list out of this bird and perhaps maybe some other word, okay? Perhaps we really like this syntax and we want to create a function. Instead of def, we use defn to create a function, and let's say this is going to be word-fn. We will have some kind of parameter like x. And for the body of the function, we will say we want list with the X and then some other word. Let's place this over here. If I just try to use the word function on its own like this, where I supply the word and I try to invoke it, the function doesn't yet exist because I need to invoke this first, and then I'm going to have the function, and then the thing is going to exist. I get back a list, and if you've ever used LINQ, you know what to do with lists. Two other main functions, defining global constants that really you shouldn't change. There are other things more relevant for having changing objects, and if you want a function, this is how you define it. There are also anonymous and local functions, lambdas if you would, that I'm going to show you in just a second. So what do we want to do? We want to go through a little bit of an example with the Fibonacci sequence, okay? We'll define a function. This is going to be fib, and we want the nth Fibonacci number. I'm going to give this a body, and we're going to use the case statement. Into the case statement goes the nth number. If the case is 0, we're going to return 0. If the case is 1, we're going to return 1. Otherwise, what is the Fibonacci sequence? It's the addition of Fibonacci, where we decrement the nth number and we add it to another Fibonacci invocation. However, here we are subtracting 2 from the nth number, okay? Invoking this, we have the Fibonacci function. If we try to get 0th, let's say we get 0. If we try to get 5th, this is 5. Let's say 10th number is 55. If we try to go to something like 50, it's going to start to run for a while. And actually it's going to run so long that what I want to do is Calva interrupt running evaluations, okay? So don't evaluate this to anything because it's going to run for too long. If I start selecting to something like 100, not only is it going to evaluate for a long time, but I'm also going to get a Stack Overflow exception, okay? And that is because we have a lot of branching and things are just evaluated to the same things multiple times. And really, again, I'm going to do another interruption on this evaluation, and we are going to come up with a different Fibonacci function. So comment this out. Let's create another fib function. So fib, again, we want the nth thing. However, instead of starting from the nth number and kind of trickling down backwards, we're going to start from 0 and 1. We will define a loop, which is going to allow us to use recursion, and the parameters for this loop is going to be a first parameter. We are going to start from 0, same as this, and then the second parameter, so second, is going to be 1. So for the body of the loop, what we're really doing is we're recurring back to the beginning of the loop, where the next first parameter should really be the second, and the second parameter is going to be the summation of the first and second. Now we somehow need to be able to stop, so what I'm actually going to have is an nth, so some kind of index. From the beginning we're starting at 0, and then we want to actually increment it. Increment I, and there we have it. Now we actually need a stopping condition. So if, let's say, I equals nth, we want to go ahead and return first, and otherwise what we're going to do is we're going to push this brace to the right, and if I doesn't equal nth, we're going to keep recurring this loop and resupplying these parameters to these parameters, okay? So that's how that looks like. Let's have the fib function. We're going to have fib5, that is going to give us 5. And now if we go up to 50, that is going to give us a big number, and maybe 70, an even bigger number. However, this looping approach is a little bit of an artifact of the past. If you're coming from a programming language like C#, you're still thinking, I have this state, I need to increment this state, and there will always be some kind of state, but with your base constructs such as lists, vectors, etc., you kind of want to start thinking in terms of these constructs and manipulating these constructs. So the fib function, let's comment this out, we'll put it at the bottom here, and we're going to have a sequence like 0, 1. We will then want to change this to sequence like, let's say 1, 1, then it's going to be 1, 2, then it's going to be 2, 3, then it's going to be 3, 5. So we almost need a function to generate the next sequence. So we define a function which is going to be next Fibonacci. We're going to be supplying some kind of list, and then we're going to be creating a new list, and actually this is going to be a vector. The first parameter is actually just going to be the last parameter of the collection. So you have things like first, if you have a collection, 1, 2, 3, 4, let's say we evaluate this, and then you also have things like last. So if you know link, you already have all of the knowledge to build this sort of stuff up. So last L, we will take the 1, we'll place it at the beginning here, we'll be taking this one, placing it here, we'll be taking this 2, placing it here, and then we'll have this 3 and we'll place it here. So this really gives us taking the last element of the list and placing it at the beginning. We then want to sum up all of these, right? So we're just taking the previous 2 numbers. For this, we can go ahead, call reduce plus on the list, and that will just sum up the whole list. Once we have a function like this, we can invoke it. We have next fib. So for next fib, let's say we will have something like this. Invoke it. Let's take a look at it. And maybe another cool thing that you can do is you can create a list over here, wrap this all up. Let's say I will take this collection. I will have a map function where I'm going to map next fib over all of these things, and I can actually inspect all of them at the same time. Let's go ahead and run that, and that is what it's going to give me. It's going to transform 0, 1 to 1, 1. It's going to transform 1, 1 to 1, 2, and then it's going to transform 1, 2 to 2, 3, so on and so forth. We can basically see that the function is working. The next concept that we bring in, and really something that Clojure uses extensively, is lazy lists. This is your IEnumerable. We have that in C# and it works with link. This is your generator that slowly gets built up and at the end you execute it. One way to create a lazy sequence is you use the iterate function, and here I'm just gonna produce kind of like a range function. I'm gonna say I want to increment the number 0, and it's going to keep reapplying this function to this value to create me a sequence, an infinite sequence currently. So what I'm going to do is I will say, let's go ahead and take 10. I'm not going to invoke the whole thing. I will run it. If instead of starting with a number, we can actually start with some kind of collection that we want to keep reapplying a function to, we can almost arrive at the same place. So next fib, let's invoke this and see what it gives us. Oh, look, it's almost a Fibonacci sequence. With this, we have the flexibility of printing a segment, the full sequence. Here, I'm going to say that I want the nth out of the sequence. So for example, something like 5. This is going to give me 5, 8. And I'm going to have to just grab the first element from here, move the parentheses on the end, and we have 5. If I want 10, this is going to give me 55. If I want 50, again, this is fast. And again, going up to 70, we get the same number. And if we want Fibonacci, so defin fib, some kind of number like n. And this is where I'm going to show you how to declare a local function within another function. What you do is this next fib that we have over here, you can create a let clause where for the scope of the let, there is going to exist this Fibonacci function. So an identifier for next fib, which is going to evaluate to a function which is going to take a list. And that function is going to return a vector. Okay, so for the scope of the function, we have next fib, and then we can take this function, supply it in the body of the let, and we have fib that looks like this. Now we just need to take the n, supply it instead of the 70, evaluate this, and we have our fib 70 again. Let's uncomment this, evaluate it, and there we have it. So maybe we want something a little bit smaller so we can actually fact check this, and we have 50. Now, you can have your function that sits there. Let's go ahead and clean up the space a little bit. Place this over here. Instead of declaring this function in the let, what you can actually do is let's get rid of it. There's going to be one dangling parentheses on the end. You can use a anonymous function. And when I say anonymous function, you can place it anonymously. You can actually just take the thing that you're declaring here, grab it, and place it here instead of next fib, right? That was just an identifier for this thing. Now, this looks pretty ugly, and to amend this, what actually should be happening is for this next fib function that I've actually managed to break, let me go ahead and fix it up real quick. So the vector that I'm returning over here, I'll recompile it just to make sure it builds. So pardon the scrolling. Basically, if we don't want such a nested structure, there is a threading operator. So to give you an example, we are going to take a collection of 1, 2, 3, 4, and what we want to do is first of all filter this collection if it's even, right? So we have a filter function, not filsec, whatever that is. We have filter, and here we can supply an anonymous function like whatever x we get supplied. We will invoke the function even x, and I will spell the function correctly, filter. On the end, we will get 2, 4, 6. Then I want to go ahead and square these numbers. So again, I'm going to declare another function. I'm going to call it x, and then I'm going to multiply it like so. The map on the end here, this parentheses, I will push it to the end and I'll invoke it, and here I have the squared numbers. So we're in the same situation where everything is essentially nested inside of itself. You can do your best effort to format it, however, there is basically a better situation, or a better solution, sorry. We take the data structure that we start working with, and then we put it through the functions that we want. So if we want to put it through filter, we just take the filter over here, replace it inside of this function. This opening parentheses, let's get rid of it. One closing parentheses on the end, and I'll put this one here, get rid of some of the space. So you will see that the parameter on the right, the thing that we're filtering, is missing, and that's what this macro does. It takes this data, it puts it on the end, and then if we want our map with the function x where we're doing the multiplication, if I can find the correct key on the keyboard, and we multiply the two things and run this operation, we get the exact same result. So the threading operator here is really what makes this sort of notation convenient. Now, where we say we have this data, put it through the next, through the next, through the next, and the function that we have over here can be made a little bit more simple. Specifically in this case, you can say, I want this anonymous function, you will remove about yay much, and instead of the x, you will have the percentage for the parameter. Same thing can be done here, where you're saying, I want to get rid of all of this stuff. This will be a short anonymous function, right? Where instead of the x's, you're just using percentage signs, and now that your code looks like this. So let's rewrite the fib function to use the threading macro. This, I will place it over here with a comment. Again, another defen fib. We are going to supply not b, but n. We're then going to have a threading macro. We're going to start with this list. This list is going to be supplied as the last parameter to this iterate function. So let's go ahead, grab it. Instead of these parentheses over here, I'm not sure what that annoying error is. Let's place this parentheses on the end, and this data structure on the end should be missing, all right? Because that's what's being placed on the end there. With this function, you would be tempted to shorten it as you do it here. However, you can't do it. You will either have to do it with the vector, and actually we can do something a little bit more simple. We can take this list and we can deconstruct it. If we put additional square braces and we say that there is a first and a second, so I'll just do F and S, where we no longer need to pick last here like this, we can just place S. And we no longer need to reduce, we just add first and S, because there's always going to be two elements. So that is how that can be simplified, and that is how that is read. Now with the nth operation, the important thing to realize here is that our result actually goes in the middle, so to the right. This is a left threading operator. You have a right threading operator, which you can write a thing to mix them together, but it's better not. What we're going to do is we're going to change the order in which these operations are performed, and generally with LINQ, order of these things sometimes doesn't matter. So we are just going to use the first function and actually place it into this threading macro over here. For all of these segments, we will just grab the first element, and then we will apply an nth to it. So the nth goes over here, whatever the result of that function, and then the n on the end. Okay, so that's the fib function. Again, let's test it out over here. Definitely an index out of bound array, because what I'm actually doing here is I'm aggregating the whole thing into a first element. I want to select the first element out of all of vectors. So what I will actually need to do is I will need to map first to the whole collection. Okay, I recompile the function, let's rerun this, and yeah, we get 55 and we get this. So this is another way to write your Fibonacci function. And I think that's pretty much all I have on this side. So we're going to close main.clj and we're going to open up docs.clj. Basically, working with big data sets is one of the canonical ways of learning Clojure and really getting into it. So what I recommend you do is you take a look at this example, what I'm going to show you here. You take your own data set and you try to perform some kind of operations on it. Whatever company you work for, you have some kind of filtering, searching operations that you're doing there. Try to write out the same things, and I promise you, you will not be disappointed. It's going to be a struggle. It's going to be painful. You're going to be asking yourself, why the heck am I doing this? If you can trust me, I promise you it's going to be worth it in the end. So let's go ahead and take a look at this. We have dog facts API. I have come back over here, the deps.eden that I have over here. I'm downloading a data.json library. And as I'm launching my REPL, it's going to automatically import this, okay? So the way that you import a package is you say require, and did I just see a snippet? Yep, require, okay. Clojure.data.json, and we can say that we want this as JSON. You can place an alias. If you don't place an alias, you will have to use the fully qualified namespace, and what we have to do is supply this as quoted. Okay, let's go ahead and try to invoke this. It's gonna produce nil, but what we can actually do now is we can use JSON read string, and if I have some kind of string of JSON, let me go ahead and produce something like this, A5, and I didn't place curly braces here, right? I'm sorry, I actually want not keyworded required. This is usually when you're declaring namespaces. So I'm going to rerun this, and that should actually do the import for me. And here I have my Clojure data structure, where if you have a map, it can actually act as a function. And then I say, I just want the key A from there, which will return me 5, okay? And if you have sets and vectors, those can act as functions as well. So 1, 2, 3, I want the 0th position, it's going to give me 1. So that's just another example of how you can use them. So read JSON, we will use it to get the JSON from this URL over here. So def dog facts, we're going to have a threading macro, have the URL. With the URL, we are going to slurp it. That is going to actually call the URL, get the data, and maybe what I want to do is get 500 facts. Why not? Get all the dog facts. We're then going to thread it to the right side of read string. This should give me a map. Let's go ahead and invoke that. There we have it. And if I try to use dog facts, take a look at it. We have a facts key with a bunch of data. So I can scroll through it and take a look at the things that we got in there. So the facts response is not actually just a regular collection. It is a key in here. So the map that gets returned here, what I will actually do is after I'm done doing this threading macro, I will actually just get the facts key out of here. Okay, so in the end, I should just have the collection. So longest, shortest fact, if we take a function like count, we can count up the amount of characters in a word. We have 4. Because this is a collection, we can, again, use the threading macro. Threading, you're going to be threading everything, okay? You're going to have your dog facts. You're going to map count, so you're going to convert all of the facts to numbers. Once you have all the numbers, perhaps what you want to do is you want to sort and just apply the sort function. If we quickly take a look at this, we have 24. 24 seems kind of small, so let's try to apply last, and I feel like that is the longest one. So the longest fact has 289. We can take this and say that if we want the shortest, we just grab the first. So the main variation is last and first over here. Now, if we define a function like L and S, so longest and shortest. We have the facts coming in as parameters. We can take this. Again, we define a function. We use the let keyword where we say that we have the sorted facts, paste the collection into here. We omit the first, and then at the end of the let, we create a vector perhaps where we go ahead and grab the first of the sorted facts. And as the second parameter, we grab the last of the sorted facts, okay? Go ahead and invoke this, then we have LNS, supply the dog facts, and there we have the function. So 24 and 289, get rid of that. And actually not using the facts, so let me go ahead and supply the facts over here. I think what you want to aim for are pure functions, okay? And now what you actually got with LNS is a quite reusable function. Whatever collection of strings you have, you want to see what the shortest one and what the longest one is, okay? So now you can actually use that everywhere, okay? Not too impressive. Let's go ahead and move on. Jokes that contain other animals. So perhaps we want to say other animals. And in here, let's say cats. A little bit weird not putting commas. Let's say maybe also rat, whale, wolf. I don't know what else relates, but yeah, let's see if we have any of these other animals. So I'm gonna evaluate this function. If we want to check if a string contains something, perhaps do we have something like contains, where we have some kind of word where we can check if it contains or. Right? Let's see if that's true. And it isn't. So contains actually works on dictionaries, right? So how do we actually do this with strings? With strings, you can get a requirement or an alias for this at the top to make this a little bit more convenient. But let's say Clojure, you will have not data, you will have a string. And then in this string namespace, you can use index of. And here in the quick actions, you can actually see that it adds a require for this. So the action failed. I'm not sure why. Can I copy this? Nope. Let me just Clojure string as string. Let's see if this runs first. Yep. So we have 1. So index of 1. And there we have it. We just need to check if whatever joke is going to be coming in, it's going to contain some kind of other value. We have the any in Clojure, but it doesn't do quite what you think. So what you actually want to use is sum. If we have a collection like 1, 2, 3, we want to be able to check if some numbers are, for example, more than 2, right? If we evaluate this, we'll see true. If some are more than 4, we actually get a nil. Where if we try to convert this to null, sorry, not null, to Boolean, it will automatically get converted to false. Moving on to the dog facts, let's say, again, threading dog facts. For all the dog facts that we have, can we filter through the facts which actually contain any of the animals? So we're going to have a function which is going to accept a fact, and then in here we're going to do something with it. Perhaps threading wasn't the best idea here. Maybe most of this should actually lay flat. So let's get rid of that parentheses, dog fact on the left, and let's start working through the function over here. The fact that we're going to have is going to be some kind of word. What we want to do is say, check all of the other animals if they're present in this fact. So maybe what we want to do is take all the other animals and start putting them through this function that we're applying to dog facts. So other animals, where we can map a function that looks like this. Let's take it, place it over here. I'll place a hash and let me actually close the Explorer. We're going to be checking index of if the fact contains the word that we're supplying, and then we want to aggregate it into sum. So sum, again, we can have an anonymous function. We can ask true. Are there some that are true? Let's see if we get any. We have nothing. Let me double check. The facts that we have here. We have cats, and actually, indeed, we are receiving integers, right? So instead of true, perhaps what we want to say, anything that's more than or equal to 0. Let's go ahead and run this. And we get a famous null pointer. So let me double check what we have over here, and we actually see nil. So maybe what's going to be smarter is asking if it is not nil. Whatever result we have over here, another parentheses, move it along, and before we do this, let's supply not, okay? So not nil is what I'm looking for, and there we have it. We have things like raining cats and dogs. Let's say if we have actually anything with whale or wolf. I'm actually curious right now. We'll take this, reevaluate this, and because we're not supplying other animals as parameter, we're kind of just using it here in the global scope. We don't have whale or wolf. Let's see if we have rat or perhaps lion. I don't know. Let's run this, and there we have it. So not exactly a rat, because we have inspiration. But yeah, hopefully you get the picture. However you want to fine tune this, you can. So how many times are puppies mentioned? If we try use the threading macro and we say, and for each dog fact that we have, let's go ahead and try to split it. The split again is going to be in this Clojure string split. If we quickly take a look at the documentation, we have whatever value is coming in and then the regex that we want to split it by. This will actually have to be mapped across. This will have to be a function, and we're splitting whatever joke is coming in by, let's say, a space. Let's go ahead and take a look at it. Error printing return value, and I think, yeah, so because it is actually expecting regex, I think, and there we have it. So that not a very helpful, or perhaps, yeah, I spoke too soon. So now we have a list of collections, right? So pretty nested. What can we actually do about this? If only there was some kind of function like flatten. What will this give us? If we take a look at the result here, for some reason it's just giving me the documentation. Let me try again, and still the documentation. So that is okay. I can maybe do something like take 10. Let's see what we have here, and there we have it. So the phrase raining cats and dogs, I can perhaps try to filter by the puppies. So filter, again, supply whatever function I have over here. And before I filter by the puppies and all of that, perhaps what I actually want to do is to lower. To lower doesn't exist. Do I get a lower? I have lowercase. Whatever parameter I'm receiving here, let's go ahead and use that. Once I have puppy, I can say or perhaps if I have some kind of, I don't know, collection of, let's say, puppy or let's say puppies. And maybe is there a puppy in there? Nope. What about if I have a hash set? If I can figure out the keybinds here, so hash set, move across the brace, there we have it. Yes, there is a puppy in there. Let's go ahead, take the hash set, use that as the function, and whatever parameter string is coming in here, let's go ahead and filter those out. And there we have a bunch of puppies. Let's go ahead, count them up. How many do we have them? We have 6 of them. And there we have it. My keybinds no longer work, so I'll have to switch the camera manually, but this will be it for this video. Please let me know what you think about it. Did you enjoy it? Yes, no, other languages better? Was this a complete waste of your time? If you have any questions, let me know in the comment section. If you enjoyed the video, don't forget to like and subscribe. If you would like the source code for this video as well as my other videos, please come support me on Patreon. I will really appreciate it, and a big and special thank you goes out to all of my current Patreon supporters. You really help me make these videos. As always, thank you for watching. Have a good day.